Hey Pre-Calc, welcome back. Hope you all are well. Our objective today is going to be to apply the rational zero theorem. I've got the checklist on the screen. You know what to do from here. All right, you don't need to write anything yet, but true or false? 6 is a factor of 12. That is true, right? And the reason is because, so why? That's because when you divide, you have no remainder, right? So 6 divides evenly into 12. You have a quotient of 2 with no remainder. So the same is true for polynomials. So if f has a factor of k minus x, the only way that works is that if k is a 0 of f, right? So let's try to, again, you don't need to write this, but let's talk this through together. If we want to show that x minus 2 is a factor of f, we can show that what is a 0? We can show that x equals 2 is a 0 of f, and vice versa. If we want to show that like x equals negative 5 is a 0 of f, we can show that what is a factor? X plus 5 is a factor of f. Okay, so same idea, analogous to what we were doing with real numbers ever since elementary school. All right, first pause on your screen. Can you just copy f of x for example 1 for me? Okay, we are back, so we want to verify that x plus 3 is a factor of this cubic polynomial. In other words, when I divide, I get a remainder of 0, right? That's what it means to be a factor, just like with real numbers here, like 6 is a factor of 12, no remainder. So let's divide this cubic by this linear. Can I use synthetic division? Absolutely. So what value should I put in this corner? I should put negative 3 in here. All right, and then let's put our coefficients in this top row, making sure that we're already in descending order, no missing terms, right, which we're good here. All right, go ahead and fill this out for me. Hit continue when you are ready to check your answer. So here's what I got for my coefficients. And so what would this first term be? 3 what? 3x squared minus 7x plus 2. And notice that my remainder was 0, so that's good news. We verified that this is indeed a factor. Now, part B says, okay, go ahead and write the complete factorization. So let's keep going with this quadratic. So I've got, let's write this. I've got this factor of x plus 3, and I've got this quadratic, 3x squared minus 7x plus 2. But let's see if we can't factor the quadratic into its linear factors as well. Notice that my leading term is not 1, so let's try some slide and divide here. I'm going to slide the 3 to the 2, so this becomes x squared minus 7x plus 6. Now we're going to factor this trinomial, so it multiplies to be 6, adds to be negative 7, so that'll be x minus 1, x minus 6. Now I'm multiplied by 3, so I need to undo that step by dividing by 3. This fraction does not reduce, so I need to slide that 3 back in front. And then this second fraction, the 6 over 3, reduces to 2, right? And then don't forget to bring down this x plus 3, okay? So there is my final answer. Notice that I started with the cubic, and I got 3 linear factors, okay? So the last part says list all real zeros. Well, remember, a 0 is a value you put in for x. That makes the whole thing 0. When it's factored, those zeros are easy to find because you just go through each factor and say, oh, make that factor 0. So you go ahead and list the zeros for me based on the factors. Hit continue when you're ready to check. All right, so setting those individual factors equal to 0, we should get x equals negative 3, positive 1/3, and positive 2. And force a pause on your screen. Can you please copy just the rational zeros theorem? So let's go ahead and put a little screen shade here. Go ahead and copy that, and we're going to fill it in together. All right, so the rational zeros theorem says that if a polynomial has integer coefficients, so that is like negative 3, 0, 1, 7, integer coefficients, every rational zero, so that's any real number you can write as a fraction, has the form, will you write this for me, p divided by q, where p is a factor of the constant term, and q is a factor of the leading coefficient. Okay, this theorem was especially very helpful before graphing calculators, but even with graphing calculators, sometimes it's hard to see exactly where your graph crosses or touches the x-axis. So this can really help us narrow down and not have to try so many different values for when we're factoring. Okay, so let me kind of first show you how to find these p's and q's. So I'm going to have you go ahead and pause the screen, and can you please copy f of x? Okay, we're back. Hopefully you paused. So our p's and q's. So remember, p is a factor of the constant term. So that is going to be factors of -2 in this case. And then your q's are factors of your leading coefficient. What is your leading coefficient in this case? Your leading coefficient is 4. Okay, so let's list the factors of 2. And first of all of this is going to be plus or minus, right? So my factors of 2, like values that divide evenly into 2, are going to be just 1, plus or minus 1, and 2, right? So now let's look at 4. So try to write all the values that divide evenly into 4. What are your factors? Well, certainly 1 and 2 and 4, right? So what we're going to do is we're going to take every possible blue piece over every possible purple piece. Let me show you what I mean. So here are my possibilities. So my possible rational zeros, we're going to have plus or minus. So I'm going to take 1 over 1, that's 1. Now keep going with this blue 1. So 1 over 2, that's 1/2. 1 over 4. Okay, now now that I've done this 1 over all my 3 possibilities in the purple, move over to your next option in the numerator. So go to this blue 2. You're going to take this 2 over all 3 possibilities in the denominator. So 2 over 1, that's 2. 2 over 2, well, that's 1. Is that already in our list? Yes, it is. All right, so I don't need to rewrite that. 2 over 4 reduces to 1/2. Is that in my list? It is. So now I've gotten all my possible rational zeros. So what does this mean? It means that if this graph crosses the x-axis at a rational value, it has to be a part of this list. So there's only 8 possibilities of where the graph could cross the x-axis at rational values. Okay, you could still have irrational zeros as well as imaginary zeros. I'm forced to pause on your screen. Can you please copy f of x in your notes? All right, so the first part says find all possible rational zeros of f of x. So that's your p's and q's. Okay, so I've kind of color-coded for us. So remember, we first take the constant term. So what are factors of 2? Well, 2 is prime, so the only factors are 1 and itself, right? So that's going to go in the numerator. What about 3? What are the factors of 3? Well, again, 3 is prime, so just 1 and 3. Okay, so now when we list all our possibilities, we're going to have plus or minus, and then take everything in your numerator over all your options in your denominator. So 1 over 1 and 1 over 3. All right, now go to 2. 2 over 1. Is that already in our list? Nope. Include it. And 2 over 3. Is that in our list? Nope, so I need to include it. Okay, so if this graph crosses the x-axis at a rational value, it must be one of these 8 possibilities, plus or minus 1, 1/3, 2, or 2/3. Let's take a look at the graph. All right, so it looks like definitely it's crossing at -2, which is in our list, and it's crossing somewhere between 0 and -1, so probably either -1/3 or -2/3, it's hard to tell. And then it's also crossing at x equals 1, okay? So let's take the 2 that we know for sure. We know we have zeros at -2 and at 1, so let's start with those and start factoring, okay? So why don't we start with x equals +1. So we can use synthetic division. Remember, put your 0 in the corner, and now let's grab our coefficients. They're already in descending order with no missing terms. So that's good news. All right, you go ahead and fill that in. Hit continue when you're ready to check your answer. All right, so I got 372, so basically 3x squared plus 7x plus 2. Now, so that was using 1, which we saw that the graph crossed at 1. We also saw that the graph crossed at -2, so x plus 2 must be a factor. So let's put -2 in the corner, and let's go again. So let's bring down the 3, multiply, add, multiply, add. Look, I got a remainder of 0, which is great news, okay, because we knew that x equals -2 is a 0, so x plus 2 should have been a factor. All right, and now I'm left with 3x plus 1. So now I can find that final 0, and my final factor, right? So I've got all my factors now. So for my first factor, I saw we had a 0 at 1, so I must have a factor of x minus 1, right? And then I saw that I had a 0 at -2, so I must have a factor of x plus 2. And then this final factor I have is 3x plus 1, okay? So then putting all those together, I could factor completely into 3 linear terms there. All right, what if, let's do some review, like what if I don't have nice rational zeros, like I can't factor all that nicely? Do you remember from Algebra 2 how we could find the zeros of a quadratic like this? Does this ring a bell, right? Quadratic formula. So let's go ahead and plug this in. So we've got, what is your A value, first of all? A is 2, B is 5, and C is 1. So I've got x equals -b, so that would be 5 plus or minus the square root of b squared, so 5 squared is 25, minus 4, A is 2, C is 1, all over 2 times A, which is 2. Okay, so let's clean this up a little bit. We've got -5 plus or minus. Let's look at the square root. Let's see. 4 times 2 is 8, times 1 is still 8. So 25 minus 8 is 17. All over 2 times 2 is 4. Okay. In my math lab, oftentimes you'll be asked to write this as 2 separate zeros. So you could have x equals -5 plus square root of 17 all over 4, and -5 minus square root of 17 all over 4. Okay? Now, here's my question for you. What do you notice about these numbers? That they come in this pair format, right? The only difference is the sign right here. Will irrational zeros, in other words, numbers that repeat forever and that you can't write as a fraction, will they always appear in this pair format? And the answer is yeah, because they'll need to be kind of put into this quadratic formula, and they'll always appear in this very kind of symmetric format where they're the same other than this sign here. Force pause on your screen. Can you do 2 things for me? Can you copy f of x, and then can you also list all the possible rational zeros? So all your p's and q's. Go ahead and hit continue when you're ready to check. All right, so my leading coefficient's 1, which is nice because my possible rational zeros just end up being all the factors of the constant term then. So we should get plus or minus 1, 2, or 4. So then it says find all real zeros of the function. So we're going to use a graph to help us, because ideally we'd like to get down to a quadratic, because at that point I can either factor or use the quadratic formula. Okay, so I see it crosses somewhere here between 0 and -1, but I only have integer values in my list, so that one's not in my list. The second one's not in my list, but this one, it looks like it crosses right at 4, which is in my list. So I'm thinking that 4 is one of my rational zeros. So since 4 is a 0, then what is a factor? X minus 4. So let's take my cubic and divide by x minus 4. I can use synthetic division and put what in the corner? put 4 in the corner. And then my coefficients are already ready to go for me. Go ahead and do synthetic division for that part. Hit continue when you're ready to continue. So I'm getting 1, -2, -1, 0 for the remainder. If you're not getting 0 for the remainder, you're doing something wrong, right? Because we know that this should be a factor, so it should divide evenly, no remainder. So this is x squared minus 2x minus 1. So this is not factorable, right? Like there are no two numbers that multiply to be -1 and add to be -2, right? So what I can do is use the quadratic formula. Let me put that back up. All right, I've got that kind of nice and small in the upper right-hand corner now. So I'm going to plug this in. Again, what is A? A is 1, B is -2, and C is -1. So plugging in here, we've got x equals -b, so -2 is going to be +2, plus or minus the square root of b squared, -2 squared is 4, minus 4 times a times c, all over 2a, and a is 1. Again, cleaning this up, I've got 2 plus or minus square root. So here I've got 4, and then I've got a -4 times 1 times -1, so that'll be +4. So 4 plus 4 is 8, all over 2, right? Okay, let's go ahead and simplify the radical a little bit. We've got 2 plus or minus 2 square roots of 2 all over 2, right? And now we can go ahead and reduce because every single term has a factor of 2 in it, right? So I can divide numerator and denominator by 2. Just be really careful because remember these are all 1s now, right? So I've got 1 plus or minus square root of 2 all over 1, okay, which I don't need to write. Okay, now square root of 2 is about 1.4, so this is about 2.4 when you add, and when you subtract it's about -0.6, and if we come back and look at the graph, you can see, oh yeah, -0.6-ish is believable, and about 2.4 is believable as well. All right, you all, that is what I have for today. I will see you next time. Don't forget to summarize.